Okay, so day 2 of solving systems of equations. Goal is the same as yesterday. We're still trying to find out where a system of equations has a shared point. At what ordered pair does it solve for both of these? However, the method we're going to use today is a bit different. It's called the elimination method. You'll see why that makes it's a pretty good name. You'll see why here in a second. This is also sometimes referred to as linear combination, sort of like combining like terms. That name also makes sense, but it probably helps if I just jump into an example with you here, and I'll show you how to solve this system using this elimination method. Now, I look at these two equations, and yes, I could, use the method we used yesterday, the substitution method, where, okay, maybe I add y to both sides, get one variable by itself, and then plug that expression into the other. You can always use that method, but you're going to see that, sometimes there are easier methods to use. We want to get really good at saying, okay, which method is the right one to use, and there's an easier one for this one, and I can do that by combining these two. Now, what I do is I essentially add the equations together. So you're going to see when I do this, one of the variables is going to get eliminated, hence the name elimination method. So x plus x is 2x. And then negative y plus y, remember look here, you're adding its opposite, right? So whenever you do that, it cancels out, it just disappears, it's 0. Negative y plus positive y is equal to 0y. And that's just going to be equal to, well, 1 plus negative 9 is negative 8. So you can see here that x is just going to be negative 4. We just divide both sides by 2. And now we do the exact same thing to finish this problem that we did yesterday, which is where we take this x value and we plug it into either of these equations. I'll go ahead and plug it into the second one here. X plus y equals negative 9. Well, that's negative 4 plus y equals negative 9. This one you can probably solve mentally. We're just going to get y equals negative 5. So I'm adding 4 to both sides. So our solution to this system of equations is negative 4, negative 5. That's the ordered pair that they share. In other words, this is the point of intersection for these two functions. Let's look at one more together here. This one might be a little bit more involved. Well, not really, though. And this one's going to be, I'm going to subtract them this time. So you'll see here, this first example, I added them, right? Because I saw these two opposites, negative y and positive y. I know if I add them that they'll cancel out. So now look at this here. What can I do here to cancel out one of the variables? Well, 5y and 2y, whether I add them or subtract them, that's not going to cancel anything out. I don't want to add 2x and 2x because that's just going to give me 4x. But if I subtract these two equations, if I combine them using subtraction, now this is going to cancel out. 2x minus 2x is 0. 5y minus 2y is 3y. Be a little careful with this next one. The signs are different. Negative 3 minus 6 is negative 9. And then from here we divide both sides by 3. We get y equals, we get negative 3. And then a little bit more work to do this time to plug it in. I'll go ahead and plug it into the top one here. So y is negative 3, which means we're going to get 2x plus 5 times negative 3 equals negative 3. Okay, so now we're going to have what? 2x minus 15 equals negative 3. That's going to get us to 2x equals 12, and x equals 6. All right, so our solution this time is going to be, make sure you write it in the correct order here. The x value is 6, not negative 3. So with 6, negative 3 is the solution this time. Now, when we meet today, I'm going to show you some tougher examples because you're going to see with some of these, there's an extra step that we sometimes have to do in order to get one of the variables to cancel out. But this is essentially the goal in every problem today. We're going to use either subtraction or addition in order to cancel out or eliminate one of the variables. Once we solve for one of them, then that final step is always going to be the same. We just plug it back into either equation and then solve for the missing coordinate. That's it, and we'll do more practice when we meet this morning.